17 pluses, 18 or so neutrons, and then it's going to have 2 electrons, 8 electrons, and 7 electrons, and it's a valence shell, right? This is also not stable. You could take 7 away or do what? Add 1. So if we add 1 electron there to that, this now has 8 electrons. But now there's 17 pluses and 18 minuses. So this ion now is chlorine minus 1. It's an anion. And if these two are next to each other, the electron we took off of this will come right over here. So this will give it the electron. And if they're near each other, opposites attract. Right? These two would attract to make sodium chloride. But ionic compounds are very soluble in polar solvents. So in water, if you put salt in water, what does it do? It doesn't stay as salt, it becomes sodium ions and chloride ions. Okay with that? In the big picture, if I mix together an acid and a base, what do I get? Salt and water. Because, for example, if we mix these two together, this sodium goes with that chloride, there's the salt, these two come together, there's the water. So there's a relationship between acids and bases and salts, and we're going to be needing to, or you're going to be hearing me say these words a lot. You know, so I want you to understand when I say acid, what does that really mean? Don't just think, oh, it's got a pH less than 7. That's irrelevant. That's just, we just measure that, right? I want you to know, what does that mean? All that means it dissolved in water and released hydrogen or something like that, and there's going to be a conjugate base. Those are the things we need to think about. The number of whether something is an acid or a base is really just a measure of how much hydrogen there is. But conceptually, what's important is, how does it react in water? Right? What does it do? So you guys okay with acids, bases, and salts? Kind of just, we'll come back to that there. Man, we did those 3 there. You saw that already. We did that and that. And lastly, what's this one? What is glucose? Sugar. C6H12O6. Is this chemical formula unique to glucose? Nope. It's also fructose. It's also galactose. Right? These are structural isomers. We'll talk about sugars. Have you heard of ketones and aldehydes? Real important for us. Okay? And we'll chat about those a little bit later. But glucose happens to be an aldehyde form of this. If we were talking about fructose, it's a ketone form. What we're looking at here is an understanding of concentration. You know, when we measure concentration, it is always a measure of solute. How much solute is there relative to the solvent? So for us, it's water, right, is the solvent. You can never measure a concentration, a true concentration of a solvent. It's always of solutes. And you can measure it as percent. So if I said 5% glucose, well, that means for every 100 molecules in solution, 5 of them are going to be glucose, or we would do it by weight. For every 100 grams of the solution, 5 grams of it is water. Okay, that would be 5%. But molarity is something that you'll see a lot. And we'll also elaborate on this a little bit later, probably Friday or next week, with even something more than that called osmolarity, which is even different. Okay? But this is simply the gram molecular weight of something in a liter of water. A 1 molar solution is the gram molecular weight of whatever that compound is. Put it in a graduated cylinder, fill it up to a liter of water, shake it up, that's it. So for glucose, we would have to figure out what the gram molecular weight is. I think people came up with 180 point something. Is that right? That is, if you took 12 times 6 plus 12 plus 6 times 18, whatever it is, 16, whatever it is, you guys remember this, right? You get a number, and that's per 1 mole, but you need 1.5 moles, so it's 1.5 times that number, fill it up to a liter of water and you get the molarity. So think about what molarity is. It's a measure of concentration. Can you get a 1 molar solution of water? Yes. only if water is in something else, right? But in your body, would you ever measure the concentration of water by molarity or percent or anything like that? Not really, because it is the solvent. And where that will come into play is when we start talking about osmosis and how we can predict in which direction water will move across cell membranes. Okay? So you okay with that kind of basic chemistry things? That's the kind of level of, I mean, obviously, you may not remember everything and you might not have remembered how to do this, but that's okay because this is not the point. But these are the kinds of things, kinds of chemistry that will be very relevant to us on a biological level when we start talking about some of the physiological processes.